Hi, this is Tony from College. So far, we did several examples of algebraic equations with multiplications, and we also did a few with divisions. Now we're going to do a couple of examples with additions and subtractions. Let's use the example of the allowance again. In this family, it is calculated differently than in the examples that we did in the previous video. Here, each child receives a weekly allowance that is equal to their age plus 5. Let's pick letters for our variables. We can use W for allowance and G for age, and 5 is the constant. So the corresponding equation is W equals G plus 5. In the first couple of examples that we're going to do, we're going to look for the allowance. We're going to solve for the allowance, so it is alone by itself on one side, and we're going to be given an age to which we're going to add 5. In this family, we have two children. We have Sasha, who is 6, and we have Malia, and Malia is 9. So let's do Sasha's equation first. Her G is 6, to which we add 5, and this gives us 11. So Sasha's weekly allowance is $11. Now Malia, we know that Malia is 9. We add 5, and we get an allowance of $14. All right, let's say now that Malia and Sasha have two cousins. Let's call them Chelsea and Naomi. And for Chelsea and Naomi, instead of knowing their age, we know how much they are getting per week. Chelsea is getting $18 and Naomi is getting $21 a week. Now we need to take this equation and modify it so G stands alone on one side. So let's do that. G equals, when we went from G, knowing the age, to figuring out W, from G to W, we added 5 to G. Now we are given W. On the other side of G, we have W, to which we subtract 5. So this second equation is going to be the one we are going to work with to find out how old Chelsea and Naomi are. Let's start with Chelsea. Take G, to which we add subscript C to indicate that we are solving Chelsea's case. Chelsea's age is equal to her allowance, which is 18, and we subtract 5. 18 minus 5 is 13. We know that Chelsea is 13. For her sister Naomi, we know that she gets $21 a week. We subtract 5 and we get 16. Naomi is 16 years old. Let's try another situation. We have Lynn and John who visit a museum, and they each buy their ticket that costs $10. Before buying her ticket, Lynn had $52. And before buying his ticket, John had $35. So we said that we have a museum ticket that costs $10. We want to calculate how much they are left with after buying their tickets. So meaning money after is what we are solving for. So we put it alone on one side, and this is equal to money before, to which we subtract the price of the ticket of $10. Let's use A for the money after and B for the money before. This is going to be our equation. So Lynn, her after equals the before. So her before is 52, to which we subtract 10. We get 42. Now for John, before buying his ticket, he had $35. We subtract 10 and we get 25. John is left with $25 after having bought his ticket. Now let's look at another case. So this is Charlie, and we know he has $74, but this time it is the money he has after having bought the ticket. So this is the previous situation with the corresponding equation. We knew how much was the money before, and we were looking for the money after. Now we are given the money after, and we will go to the money before. So we are looking for the before. We put it alone on one side, and we know that this money before is equal to the money after, to which we add the $10 that were there until they were spent on the ticket. This is the equation we're going to use with Charlie. We don't need this anymore. Let's erase it. So we get the before for Charlie is equal to how much he has after, which is 74, to which we add 10 and we get 84. Charlie had $84 before spending $10 on a ticket.